Good day and welcome to Undergraduate Introduction to MIG Welding and Related Shop Safety to Welding. My name's Robert Smitty Smith. I'll be your instructor, and this young lady is Karen. She's an engineering senior next year, and she's volunteered to help us out with this little workshop demonstration. Now, what we're talking about today is welding. Welding is the joining of two or more metal parts by melting them together. It's not soldering, because soldering is surface attachment. We actually have to bring the metals to a molten state, and the two different or more metals flow together. That creates a welded joint. Now, in order to do that, we have to use some welding equipment, because the kind of heats involved are not attainable by normal means. So the steel, as engineering students should know, melts at about over 2,500 degrees Fahrenheit. So in order to create a weld, we have to create temperatures in excess of 2,500 degrees. And we do that with an electric arc machine. Now this is a MIG welder. MIG stands for Mechanized Inert Gas Welding. The mechanized part is the electrode is fed by an electric motor down this long tube into the torch head, and we adjust the speed by adjusting the feed speed here. We adjust the power that we need by adjusting the upper knob. That controls the voltage. It's very simple and it is very fast. Now MIG is used in industry more than any other form of welding because it's simple. The machine does a lot of the work for you. With a stick welder, where you have a long electrode that's flux coated, it takes more technical skill to manipulate the stick. And TIG welding, which all of you have heard about, I'm sure, uses a handheld filler rod, and the electric arc just generates heat, and you feed your electrode in with your other hand. It is very, very much slower than a MIG. A MIG is 5 to 6 times faster than any other form of electric arc welding. That's why it's used in industry. It's very easy for a beginner to pick up and create very, very good, strong welds that are very neat and have structural integrity. So it is the welding system of choice. Now, as far as safety goes, when it comes to shop techniques, the first and foremost, you are never, ever to work in the shop alone. It's the buddy system, just like swimming, where sharks are, where you go in the water after a meal and you get the cramps and sink and die. You always have a buddy to help you out, because you could set yourself on fire, you could burn yourself. We're dealing with a lot of heat, a lot of electricity. It is not safe to do this alone. We insist that you always have another student with you in the shop to do any form of welding. Now, you also must know where the phone is in case there is an incident, and you must call 911 for assistance. Phone is over by the computer. There's also a first aid kit on the wall. And we want to adhere to these policies religiously, to the letter. No exceptions allowed. You must always wear the proper protective clothing. And you must always follow manufacturer instructions. Any labels, there are labels all over this machine of do's and don'ts, and it's foolish to take chances like if the floor was covered with water and you're dealing with voltage. Not a good idea. So use common sense, follow the manufacturer instructions, wear your safety gear, know where all safety and emergency equipment is located. Fire extinguishers, make double sure you have one that's charged and tagged and certified operational. Look around the welding area, police up any paper or plastic, because welding generates molten sparks that can ignite virtually anything. And that's basically it. And as soon as we get kitted up with our protective clothing, we'll be ready to start. So over here, we have leather jackets for the very large, normal, and smaller students. We also have a leather apron. Now, if you notice, leather, leather, leather. Leather is the preferred material. Synthetic materials are not preferred because they're made out of petroleum. They can melt and burn. Leather is the best. Next to leather is wool. Following that good is cotton. This is actually a lightweight helper jacket that's cotton, and it's treated with a fire-resistant chemical so it will not ignite. This is what your helper or your instructor who's standing to the side can wear, who's casually exposed. The welder always has to suit up with leather. And we have leather insulated gloves because the hands are very, very close to these very high temperatures. So we're going to get Miss Karen suited up here, and then we're going to do some welding. So here you go, Miss Karen. This is the for you. Always want to watch, if you have long hair, always make sure it's inside the jacket. If it dangles down, it will burn. Now, welding generates very harsh ultraviolet light. You must cover all exposed skin, especially your neck and arms. Otherwise, it will give you a very, very severe sunburn. It can create quite extensive skin damage. The welding helmets have an auto-adjusting lens in them. They allow you to look through, very much like dark sunglasses, to see what you're doing. They will automatically darken down as soon as the arc is initiated. You must always have a protective helmet on because at this range, the ultraviolet light can cause severe retina burns, which are very painful, and they do heal, but they will give you a night of misery with aching eyeballs. This is not to be played around with. Now, take your gloves off, Miss Karen. I'll show you about the helmet. Now, this is how you adjust the welding helmet for size. There is a wheel on the back. It's spring-loaded. If you notice, I'm depressing the spring. Then you can rotate the wheel, and it will size the hoop that goes around your head properly. So basically, you put it on your head, like so. You press in the knob, and then you rotate it till it's comfortable and firm, but lightly firm. These are plastic, and if you over-tighten them, you will strip them out, and we will be very upset because these are expensive. The knobs on the side adjust the tension that hold it up, and so you can pull it down and raise it, and it stays without flopping around. So you just use mild, firm force on this, not severely strong. And that's basically all there is to the helmet. There's an intensity knob on the side. Generally want to run about number 10. If you can't see the arc and what's going on, you turn it down to 9. If it seems very bright, turn it up to 11 or 12. Just adjust it to personal preference. So let's see, turn to Karen, and we'll set yours. Yours is set at 10. That's correct. Now, go ahead and take your helmet off. So we've got our gear. Now we're going to prepare the torch and actually do some welding. Now, it's normal shutdown procedure on these torches when you get through with them to leave them dirty. The reason for that is they're hot, and it takes a while for them to cool down. So you see this extended out. It means that the inert purge gas has been bled out of the system. The torch was shut down and left. And if you can see inside here, it's very black, and there's little BBs of molten steel in there. We need to clean all of that out so we have a nice clean torch to start with. If this is allowed to accumulate, it will create heat concentration, which will overheat the torch tip and cause a malfunction. So all we do is screw off. This is the gas nozzle. Inside is the guide tip. This is what the electrode wire comes out of. And if you notice, it's all blackened with carbon. So what we need is just a shop towel. If this has been treated properly, then all this stuff just sort of wipes off. And we have nice shiny copper again. If it hasn't been treated with the maintenance that it deserves, then you can't wipe it off very well. And the nozzles, the tips have to be replaced. But this is coming off. It's a little stubborn on the tip. That's normal because these things run very, very hot, and you create a lot of carbon in the process. So I don't know if you can see that, but that's a lot cleaner than when it started. So we stick this over here where this won't fall off on the floor. We take the nozzle. We have to get all this crud out from the inside. Here we have MIG pliers. These MIG pliers are very special. They have on the tines here, they have sharp outside edges. These sharp outside edges are for insertion into the nozzle and rotated, and it will scrape away any of the steel BBs that are caught up and crunch. You can see the buildup here that's coming off. So you loosen them all up. If that is allowed to build up, it affects the purge gas flow. It causes the tip to run hot. If the tip runs too hot, the wire will melt coming out, and it will wad up, back up, and it'll stop feeding wire into the weld. And you have to shut down, and then you have a real mess to clean up. So basically, we just insert a rag in there and we wipe it out. You can probably see the nice shiny copper now. So we clean this up. Now, we have to treat this to prevent that buildup from becoming too severe. Here we have anti-splatter nozzle dip. This is a high temperature grease. It acts as a release agent. We put a little bit on sparingly. Now we need to put it on the inside of the nozzle. That's where it really needs it, and a little bit on the outside. So how's the easy way to do that if you can't get your finger down in there? Easy. Here's the grease. You take the nozzle, see the bevel ends right here. That's how far we want to coat it. So we insert it in the grease, and then we slowly twist it, and we insert it into the grease down to the bevel. Without stopping the twisting, we bring it back out. Now we're coated inside and out with the release agent, which will retard that buildup greatly. Now there's surplus grease on there, so I generally take this with my little finger, like so, wipe off the surplus, because all we need is just a thin film, and we go to the wire tip. You can do this with a cotton swab if you don't like the fingers to get greasy. And we coat mainly the nose. That's where it really needs it. See that? We coat the nose with the grease. And we just smear it around, and now the tip is treated. And we can weld all day with it like that, and that will prevent the severe buildup. Now, if maintenance has been deferred, sometimes these don't come off readily. These pliers have serrated jaws designed to grab, to loosen a stubborn nozzle. They have smaller serrated jaws designed for grabbing a stubborn tip. See that? They have side cutters for trimming off the excess on the wire. They have the sharp outside tines for cleaning off. These are specialized deal. And you can also use them to pick up a hot part and set it to one side without burning your hand. So basically, we've cleaned that. We reinsert the nozzle. We screw it down. Take the side cutters. We cut off the surplus wire. This is basically ready to go. Now we have a clean tip and a clean nozzle. We're basically ready to go. So we come over here. This machine's just plugged into a wall. Make sure it's turned on. Now come around here, Miss Karen. I'm going to show you this. Now, I turn the tank where you can see the gauges. Can you see the gauges? All right. Now this is the pressure in the tank. Right now the tank is shut off. There's no gas coming up. This is the pressure going to the torch tip. This is your purge kit. Excuse me. You want to open the valve slowly. If you just snatch it open, what happens, you get a tremendous 2,000-pound pressure surge, runs up, hits the regulator, boing, and it can damage it, right? So we want to ease it open, so we don't shock the regulator. Because these regulators can last, see how the gauges, they just smoothly swung up. Now we open it another complete turn and a half. That's so we aren't restricting the flow. We look over here, we want to have 25. That's what we want, see? We want to adjust the pressure to where we have a flow rate of 25 on this gauge, delivering it to the machine, and now we're good to go. We look over here, we have 1,800 PSI still left in the tank. We always want to turn these tanks off when we're done because it costs $100 to recharge these tanks. If you leave them on overnight, or worse yet, over the weekend, A small amount of leakage occurs, which empties the expensive purge gas, and it's just very wasteful. So we always turn them off. Plus, the pressure being on the system is not good for the system. All right, we have purge gas. Now, it's been shut down overnight, so that means any purge gas that's been in the system and in the hose has gone away. So we need to reestablish that. So we turn on, here's your off-on switch. You hear the motor run. We let it run for about 20 to 30 seconds. That's just to allow the transformers to warm up. Then we're going to pull the trigger. This is your trigger. We're going to pull it, and we're going to run out about 10 inches of wire. What that will do while the wire is running out, it will allow gas to flow and reestablish itself all the way through the system. So when we actually weld, we have purge gas at the nozzle. So these are not accelerator switches. It's off in its own. The worst thing you can do to a welder is sort of blip it like that. You want to be definitive. Pull it and hold it. See the wire coming out? Stop. Hear the gas hiss? So we've refilled the line with gas. We trim this off. Now, it's absolutely 100% ready to weld at this point. Now I'm going to turn it back off because I want to show you. Let's come back around here. Put your helmet back on. I'll put my helmet back on. Now I want to show you how to hold the torch. We have a hilt here, a little built-in boss. You want to keep this finger, treat it as if it was a firearm, right? You want to keep that finger out straight because as you're handling it around when you're getting ready to weld and you're moving things around, you click, click, and it's running out, click, click, and you cannot start a weld if you've got the wire extended out away from the nozzle. So you have to trim it back every time. So the way you hold it, 3 fingers here under the hilt, like so, and you hold it like this with your thumb on the back side. And then when you want to weld, you bring it in and you firmly depress. You hold it, then you definitively release. You don't sort of lightly sort of mess around with it. You pull it in and you release. Okay, so you hold it and you show me. Okay, right with your finger, and you feel like you got control. Now move it around, point it here, point it there. Because what you don't want to do is accidentally trip this. And with these thick, heavy gloves, you don't have a lot of sensation of touch. So if you do it accidentally a few times, no harm, no foul. But be aware, it will do that on you. And so you have to consciously think to keep that trigger finger extended. And that's basically it. All right, now put the gloves on and let's try it with the gloves. There we go. We want to pull them in. These are gauntlet type gloves. Gauntlet gloves come up past the wrist. And you get your jacket inside. You will see sparks when we're actually welding coming off. Those sparks are actually molten spheres of steel at 26 to 2800 degrees Fahrenheit. They will burn through skin. They will burn through nylon, flesh. And if they have any size to them, they can really be painful. We want the leather to soak up those little sparklets and not your skin. So we want nothing exposed. Okay, now hold the torch with your 3 fingers. Great. All right. All right, now I want to turn it on. Give the transformer a second to warm up. All right, now it's not going to do anything because the electrode's not going to touch anywhere where it's grounded. So just pull the trigger. Feel that? Stop. Do it again. Stop. Good. Now, with your other hand, now notice you only got cutters on one side of the pliers, and you want the cutters next to the nozzle where it's as short as possible. So try to do that with the pliers. It's a little clumsy. Yeah, see, the big heavy pliers make it a little clumsy. There you go. Click. Let's see, you may be on a dull spot or too high. Let's see, try it again. Let's see. Let's see if there's something wrong here. You're just not squeezing hard enough. We're going to have to get you a rubber ball at the gym. Okay, squeeze the trigger, pull it out again. All right, try it again. If you can't do it with your left hand, you'll have to swap hands with a torch, right? And do it with your dominant hand. Whoop. No, you're up too high. There you go. No, get a better grip. And see how accidentally it is to trigger? That's okay, that's normal. You'll get a feel for it. Now here's the deal. Don't have your pliers like this. Don't have them like this. Have them flat against the end. See that? Flat against the end, and then pull that and squeeze them like that. Very good. All right. Now you're ready to go. Okay. Now, I'm going to put a piece of metal on the table. This is the ground electrode for the welder. If you see, I have a nice thick aluminum sheet, so I click it over here. This creates a ground plane anywhere on this. If I have a piece of metal anywhere on here, it'll create an electric circuit for the welder. So we'll come over here to the side. I will clamp this down. This will ensure excellent electrical contact. Now, swap sides with me. Now, what we're going to do is a spot weld. A spot weld literally means a spot. Here's an example of a round tube joined to a square tube with 4 spot welds. Can we see that? This is called a fillet weld. This is just a straight joining weld. And we want to do that in a symmetrical pattern to hold the tube firmly on the square stock. So that's a successfully spot welded together joint. Then later we just connect the dots and make a continuous weld from spot weld to spot weld. So that's how you join metal together. But first we got to learn how to do a correct spot weld. Now, the gas flow comes out very softly. If there's a lot of drafts and wind, sometimes you have to crank up the gas flow to maintain the protective blanket that keeps oxygen away. Or we have to create scrims around to block off any drafts because we must maintain our inert gas purge. Now, the absolute best way for the inert gas purge is to put it at 12 o'clock high, pointed right down at it. But there's 2 problems with that. If we want to make a weld like that, all the splatter that comes off goes right back up into the nozzle and builds up very quickly. Plus the fact we can't see a darn thing what we're doing because we're behind the nozzle and we can't really see the action that's going on in the molten area. So what we want to do, we want to angle it to the side, and for the beginner, it's okay to allow the edge of the nozzle to rest on the work and keep it totally under control. For a beginner, most likely, if you can imagine a helicopter in a very high wind, it winds up being something like this. This will not work. You have to pick a spot in space and you have to hold it there. But for a beginner, especially for spot welds, if you let it rest right here, it won't move around with it. And to do a spot weld, and a lot of people get off on the wrong track of spot welds. They do not understand 2 things. One, to do a weld, you have to bring the darn temperature all the way up to 2,500 degrees Fahrenheit. You have to hold the trigger down long enough for the metal to heat to a molten state. If you just do a quick little bzzz, there's not enough time for the energy to flow electrically in there and heat up. Feel that. It's like 65 degrees, 70 degrees, just ambient temperature. It's got to go from ambient to 2,550 degrees. It takes a definite number of milliseconds to do that. The magic number for this material, which is a 1.5 millimeters thick, is about 2 full seconds. We want to put it there and we want to pull the trigger 1 Mississippi, 2 Mississippi, release. That 2 full seconds will allow enough electrical energy to heat the metal up and create a spot weld that's proper. Any shorter than that, you'll have a cold spot weld with very, very poor adhesion, almost no penetration. Now, we'll do some, and I'll show you what a short one looks like, and what a long one medium looks like, and what one that's long looks like. It actually will create heat circles in the metal. So if you look right here, see the diameter of this color change in the metal? That heated more than adequately to bring it up. If you look at this one, smaller. This one took place in a shorter period of time. So what we want to do is to give it enough to where we both deposit enough filler material and heat the metal up to molten. The biggest problem with spot welds is they're cold. There's not enough time's been given to them. What's the number? 2 full seconds, right? 1 California, 2 California, release. And the beginner tends to go, zzz. You tend to be a little gun shy of it because it is electrical arc after all. But it's not going to shock you. You're holding it insulated. This is creating the path here. It's very low voltage. If you're not standing in salt water or something like that, it's going to flow between the metal because that's the path of least resistance, not through you. Okay. And we have gloves, which are another level of insulation. Okay. So I will do 1 or 2, and then I will let you do them. So we have purge gas. All we need now is electrical power. Now, it's normally good shop procedure that you go preparing to weld and you get your shields around. If there's anyone else in the room, you say immediately before you pull the trigger and strike the arc, you say welding, and you give it a beat to let everyone turn their eyes away, because if other people are in the room, they should not look at this electric arc. It has ultraviolet coming off of it. All right? Good. Okay, I'm locating it. And I'm not going to move the head. For a spot weld, you do not have to move your head at all. Welding. Two seconds. Now, I don't know if you can see that, but there's a ring. See that color ring around that? That's the penetration. Now, I also want you to see that the end of the wire, before it had that nice sharp tip. Right? Now it's got a molten ball. That ball is more difficult to melt the next time. So if you want to trim that away, if you want to initiate nice, clean spot welds, you start off with a nice sharp electrode wire every time. Once the part heats up from welding a few times with a spot weld and there's actually a little heat in it, you don't have to do that. But when it's cold, it's best to do that. All right, I'm going to do another one. I'm going to do it very, very short. Welding. Now, difference is night and day. See how there's no ring? There's no penetration. There's no heating into the metal itself. That is that would create a very, very weak spot weld. If I took a piece of metal and put it against it and did that kind of weld there, I could just pop it easily. This one, I'd have to tear it apart with some pliers or something. And that's the difference. All right, Miss Karen, let's let you do it. Swap sides. Also, if you have some rusty metal, a little steel brush to scour away the rust, always a good idea. All right, so it's okay. All right, let's give you a nice sharp. There we go. Hold it underneath, 3 fingers underneath. Okay, you can go ahead and sort of place it and get an angle. You want to be at a slight angle of 15 degrees or so. Now notice how I'm pointing at a skewed angle. Always try to get the nozzle in line with the work and then control the angle this way. If we allowed it to come down too far, our purge gas just floats off into oblivion. We want to keep it up fairly high, but not so high that we can't see the part and where the arc's going to hit, okay? All right, lower your shield. Remember to say welding. Okay, now, what happened there is that 2 things happened. One, you didn't quite give it enough time, and the tip came off the work. So what I want to do is this time, dry run it. All right, take it. Okay, get comfortable. You can actually use 2 hands if necessary. Put it there and let it stay there. Just let it lean on it, okay? I don't want it to come off. Now, pull the trigger and count 1 Mississippi, 2 Mississippi, release, all right? And I don't want this to come into the air or slide around. I want to just let it be still. And let it stay there after you release for a split second. Sometimes if there's a little gas flow flowing, it'll continue to flow and keep it clean. All right, I'm going to turn on the machine, lower your shield. Oop. Okay, try it again. A little longer. Basically what we've got here, I think we've got the hose in a little tortured path, okay? Okay, that was better. That was better. If the hose gets kinked up and twisted too much, you'll hear the motor strain. A lot of welding is listening to the machine. I don't know if the microphone's picking it up, but there's a sizzle when the spark initiates and it's burning. It's like a steak on a stove. That's what you want to hear. The one thing you don't want to hear is pop, 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 pop. That's very, very bad. Stop immediately if you hear a pop, 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 pop. Okay? So that was good, except that was 1 second long. See how you don't have a penetration ring? All right, come back right there. And I will tell you go, and I will count it out loud, and then I'll tell you to release. All right? So get that nozzle down. Get comfortable where you can hold it. Welding, squeeze. 1 California, 2 California, stop. Good. Now you had a little hiccup in the middle, but if you can see right there, now you've got a temperature ring that's shown, right? Ah, very good. All right, we're getting there. This is the weld I did. This is the weld that I did too quickly. This is Miss Karen's, which were too short until this one. See the ring? That's what you're looking for. If you've got a ring, you've got penetration, you've got a proper spot weld. And that's all there is. You don't have to move the torch around the spot weld. This is the simplest welding there is. And until you can do it properly, you can't join metal parts together. We will cover how to do continuous beads in part 2. So that's basically, you've done a spot weld. Let's do another one just for insurance. I'll give you a nice clean metal to start. Okay. There you go. Get your nozzle down. Welding. All right, you're still a little too short. Your sense of time, just extend the time. Do it again. 1001, 1002. Perfect. Sometimes you have to do that before you get the proper sense of it. It's just an internal clock type thing. Now, same thing, look at the rings, right? That's all there is to spot welding. Now, I'm going to show you how to shut the machine down. Okay, you've done all your welding, you've built your project. Now this thing is hot. We don't really want to clean it because it's hot. We'll burn ourselves. So we want to make sure that we put this to where it's not going to fall off on the floor. These nozzles have a ceramic insulator. If they fall off the tabletop, hit the floor, it shatters the ceramic. $25 is what these nozzles cost, and they are destroyed every time. So I like to hook them, turn the machine off, hook them in the handle, drape them over the table, just pay attention so we don't damage the thing. Now, we go over and we turn the gas tank off. So walk over, take your helmet off. Whoop, there we go. Take your gloves off. Walk around. It's really important we close this because the gas is a precious resource. Just feel how much force it takes. Okay, that's opening. Clockwise is closing. Yes, clockwise is always closing, counterclockwise always opening. Right, and give it a good ink. Yeah, two-handed ink. Now, We have trap pressure on the gauges and in the system. We don't want the system to sit with trap pressure. It's bad for the system. So turn it back on. Pull the trigger. No spark will happen. And watch the gauges go down. Just see? Once they're emptied, now turn it off. You're done. Hang up your jacket, put the gloves back, hang the helmet up, done. And that's all there is to it. Now, just to reiterate, never work alone. You can get shocked, you can get burned. Always know where the fire extinguisher is, where the phone is, where the first aid kit is. Follow manufacturer's instructions. There's plenty of safety placards over these machines. One thing I didn't show you in the beginning is where the electrode actually comes from. This wire that comes out the center, and it feeds it into the work for you. It comes from this big spool of wire. That's an 11-pound spool of wire. Comes off slowly. There's a friction drag on here so it doesn't spool out on you. Comes through here, you have mechanized rollers. That's what this speed knob controls, is how fast these rollers drive that wire down. It's very simple. There's a spring-loaded pressure wheel on the upper wheel, and that's what motorizes it and does the work for you of feeding the electrode. Here you have MIG gasless flux core. You can buy special electrode wire that has flux built into it. It gives you very inferior quality compared to what the premium purge gas gives you. We're using this. As you can see, you have scales here. CO2, straight carbon dioxide, can be used as a shield gas. It's inferior to C20 or C25. That is argon and CO2. Here you have your sizes of electrode wires, either 25 thou or 30 thousandths of an inch. This is the heavier 30 thousandths. And here, if you follow this chart, it gives you the thicknesses of metal that you can weld and their corresponding settings for the dials on the front. If you don't have any other thing to go by, you can take the metal, put it up here and say, that's that thick. Come down here. Okay, I should be at F4.5. Set the machine, weld. That's it. So, we'll cover more advanced techniques in part 2. Thank you for your time.